Pretty quick. I should, but who knows? Maybe it'll feel more complicated than I was assuming. Up on the whiteboard, I put the 3 new formulas you need to know. You do not need to know cosecant, secant, and cotangent. On the AP test over the last 25 years, I have only ever seen these 3 arc functions. I guess I should have started with, in your pre-calc book, I can't remember, I know what the old book used to use, but I don't know about the new one. Does it use the notation with the -1 symbol, or does it call it arc? Did it use both? Oh, okay. So that's kind of one strange thing about the inverse trig functions, is sometimes the notation is going to have the -1 symbol, other times they write arc. Zero idea why there's both. But they mean the same thing. So if you ever run into it, that's what you're going to have. Should I start by even asking you what these mean? Like, it's one thing to kind of just like memorize a formula and like find answers. And to be honest, I have zero doubt you'll be able to do that today, no problem. Does anybody even know what they stand for, though? Like, if you're actually writing down the derivative of inverse sine, what does the answer stand for? Do you remember what inverse sine stands for in the first place? Should we go with that? What kind of answer do you get when you do inverse sine? You get an angle size. So regular sine, regular trig functions, you're trying to find the ratio of the sides of the triangle, like how big they are compared to each other. So like sine of 30 degrees, or pi 6, an answer of 1/2 means the opposite side is half of the hypotenuse. It's telling you how they compare. When you're doing arc functions, it's giving you an angle size answer. So you would type in your calculator sine inverse of 1/2, and that would tell you that the answer is a 30-degree angle. So what would the derivative of arc functions give you? What does derivative even stand for? Don't say slope, which is correct, but it tells you how fast it's changing. So if we're doing derivative inverse sine, it's telling you how fast the angle size is changing. So for whatever reason, you might have some sort of shape where the angle is moving or changing. And this would be one way to find out how fast the angle's changing. So it is helpful to know what these things stand for. And honestly, it kind of feels completely separate than learning how to find the answers. Because a lot of Calc 1 is us just learning how to find answers. Because there's so many new things thrown at you that it's helpful to just know how to find the answer. And then what you're going to find is there's a Calc 2, there's a Calc 3. Calc 2 is traditionally like sequences, series, but it's still one variable, like an x, something like that. When you get to Calc 3, that's usually considered a multivariable calc. So you do all the same topics that you did in Calc 1 and Calc 2, but you do it in more than one variable, more than one dimension. So frequently it's a 3-dimensional thing that you're dealing with. Because you're still trying to find out how fast something's changing, whether it's in 2-dimension or 3-dimension. So that's kind of how Calc progresses. So my guess is you'll learn how to do this year. And then when you see this again in Calc 3, it'll probably make more sense what you're actually doing. That's traditionally the route. So don't feel bad this year if you feel like everything you're doing you don't understand at all what's going on, but you know how to find answers. That's kind of normal. If you do understand it now, that's great. But just know that it's like this topic is really easy to highlight that. Okay. Let's go with Ian. We gotta wake Ian up. Ian, are you ready? Okay. I feel like we could probably do some of these without me like giving any guidance at all. So if I look at box A, oh, I am 100% skipping the proofs that were on page 1. I feel like that would make you more confused than benefit you.
So you don't have to do those type of problems with the triangle.
That's just how to, so the triangle just comes up with the answer. Okay, Ian, if I'm looking at A, I've got y equals inverse sine of 5x. Now, if you're looking at all those formulas on the sideboard there, they all have a u in them. So what would u be on A? Perfect. Do you think you can come up and write the derivative answer up there already? We can give some guidance if you want it. So the advantage of using formulas is like you just fill in things. That's why I thought today's section would go pretty quick. So what, if you write dd of x, you would write that on the original problem, because dd of x is you just saying you're taking the derivative. Otherwise, on the next line, if you write y prime, that's the other way of saying that that is the derivative. Sort of perfect. I mean, it's not wrong in any which way. Obviously, a final answer wouldn't have 5x squared. It would have 25x squared. But yes, that's it. That's all there is to it. By far, what gets more complicated is just what's going to be in place of u. Okay, should we, do you guys like calling on other people? Do you like rolling randomly? Oh, so it's like 50-50. We should make a new person roll. Oh, you have somebody you want to pick?
Yeah.
Wow, that sounds quite nefarious, evil. Okay, who are you picking? What? I thought you had somebody you wanted.
Definitely check it.
Okay. Is that enough? Fair enough?
Yeah.
Okay. Up there, any particular one you want to do?
I'll just do B.
B?
Yeah.
Perfect.
Try to go over there.
Yeah. You guys are teaching today. I still get paid, but you're doing the teaching.
First, I would do. Wait, can I bring my thing to see the formulas?
Formula's on the board next to you.
It's right there. Oh, I just got this.
Oh, like you already wrote it down on the paper? Sure.
I just read it.
I got you.
Alright, so another way of writing this without this could also be.
Oh, gotcha. Okay, yep. You absolutely can write that as the half power to start with. Sure.
And then,
Don't take this the wrong way, but I have no idea what you're writing.
1 over 2 over 2x plus 1 over, that's isn't that the front?
Oh, that's your derivative.
Yes, right?
Okay? Yeah, no, that's fine. I just partially didn't know what you were writing. I can zoom in more if you want to, so because it won't feel so crammed.
That. I erased this.
So currently, This is 1 over 2 root 2x plus 1.
Yes.
That's your derivative over 1 plus 2x plus 1.
Yes.
Okay. We forgot something minor up here. You're very close. The derivative on top is very close. So I'm assuming the 2 on the bottom came from the 1/2.
Yes.
So the derivative of 2x plus 1 to the 1/2 would be 1/2 parentheses to the negative half. That's where you've got your root on the bottom.
Yes.
Times derivative of whatever was in the parentheses. So there would be another 2, and then that would cancel out the 2 that's on the bottom. And then were you trying to figure out how to write those two things together?
Yes.
Got it. So the way I do it, which doesn't have to be the way, is if I have a fraction on the top, I would write the information as a fraction on the bottom. So then you could just write the bottom as 1 plus 2x plus 1 all over 1. And then you take the top fraction times the reciprocal of the bottom. Can anybody else read that okay too, by the way? Or follow it? This one has a lot more information than the first one, so.
I don't know how I would simplify.
Nope, that's right. That's it.
That's it?
So simplified would just have it in a parentheses instead, like one whole bottom. That's good. I'm going to zoom in because I feel like I need to rewrite it because it was so small. It was hard for you to write. Do you guys want me to start that one over then? Sure, I can do that. You did it perfect though.
Sure.
Nice job. Okay, so u prime goes on top. So derivative of square root of 2x plus 1 will be on the top of the fraction. You can do this part multiple ways. Chendron?
Chain. Chained it.
Chendon?
Chained it. Like a chain, and then chained it.
That's a good way to remember that. Okay, chained it. He wrote it as a fraction on the top. And I'm sure everybody here writes things slightly different. So the derivative of 2x plus 1 to the half power would be 1/2 2x plus 1 to the negative half times 2. The bottom is going to be 1 plus whatever the u is squared. Now because we've got a square root, when you square it, it becomes just whatever was inside the root. Now the simplifying of this is probably where most of you might have a difficulty. We'll start with the 1/2 and the 2 cancel each other out. On the denominator, there's no need for a parentheses anymore. So this becomes 2x plus 2. So we're pretty much only left with two things. That thing on the top, which is a negative half power, so we would move it to the bottom, and the thing that was on the bottom. The order you write them really doesn't matter. Two. All of these, we're just going to be filling up the formula that's there. Probably the most work will come in all the simplifying, which I know traditionally is probably the part you're the worst at. Just given by all the tests so far. It seems weird to me that you guys are very good at the calc part and not as good at the algebra. And I don't know if that was because you guys were very good at algebra, so you kind of halfway blew it off and just did stuff because you knew you were going to get an A. I don't know.
Why wouldn't the 2x plus 1 on the bottom be squared?
It was. So the u was the square root. So if I write the square root and then square it, the square root and the square root cancel each other out. So that's why on this one I just wrote a parentheses.
Okay.
Are we okay with this one? Okay? You guys feel like you could try C and D on your own? Why don't you do that? Or the ones below them, are they worse? No, the E to the X isn't worse. E looks, you guys probably wouldn't like E, huh? Let's do E. That one looks fun to me. I feel like E is gonna simplify a lot, just because of what was chosen. You're on your phone a lot.
This is like,
Calc formulas?
yeah.
Wait, what do you need them for on this one?
I just wanted to, it's like, you know, like the one where it's like 1 plus like cosine squared, or like 1 plus sine squared.
Sine squared plus cosine squared equals 1, yeah.
I just wanted to.
That's, yeah, you're right, that's on the trig one. No. Sine squared plus cosine squared equals 1.
We simplify this to negative tangent.
I don't know, I haven't done it.
I probably did it wrong. I ended up with negative sine.
It might not simplify at all, I was just guessing. I haven't done the question. I like doing them with you guys.
If you had negative sine over cosine squared, you turn that into tangent.
Oh, yeah.
Oh, yes. Yeah, so you can separate the cosine squared into cosine.
We actually.
So then, when you have negative sine over 1 plus cosine squared, are you
Nope,
1 plus cosine?
you told me just cosine squared.
It is 1, it's 1 plus.
Oh, that's different. That can't be separated.
Sadness.
Oh, that's too bad. I haven't done it. I was wondering if it would simplify because I knew there was going to be a cosine squared, but I have no idea. Oh, just garbage.
Yeah.
Here, I thought you were going to. Yeah.
It's just because
Because they're flexible, the same exact thing. Except one is the same.
20. Brendan. Didn't you go first yesterday or something too? All right, well, you got rolled again. I was hoping you could go up there and do E. How confident are you feeling? Do you want to confer with people first, or have you already done that?
I'll go simplify it all the way.
Oh, that's, I didn't know if it was going to simplify or not. I frequently like to do questions with you guys for the first time. I don't like doing ones that I know the answer to because it gives me a different perspective if I already know the answer. Now, when I was talking about I felt like it would simplify, that's because I knew there was going to be a cosine squared, and sometimes that's set up where it might simplify. How come this one doesn't simplify?
Well, the bottom is.
Quit whispering everything to him. You're screwing him up. Okay. What did you check for with the cosine squared? Probably. What's the one thing that we frequently have that has sine squared and cosine squared that it interchange? No. Well, I mean, that's true too. But so sine squared plus cosine squared equals 1 is one of the Pythagorean identities.
Yeah.
And that's part of a lot of our problems. And if this would have said cosine squared minus 1, or 1 minus cosine squared, then we could have replaced it, because that's a version of the Pythagorean identity. But 1 plus cosine squared isn't anything. So it doesn't actually change out. Are you guys okay knowing what I'm talking about when I say 1 minus? Oh, okay. Yeah. So that looks like it's just going to be the answer. And even if it was 1 minus cosine squared, then we probably could have done some kind of replacement factoring. I don't know, whatever we want. But 1 plus cosine squared is, well, that's what it is. It's nothing. It doesn't replace with anything. I guess if you were really bored, you could replace cosine squared with 1 minus sine squared, but I don't know if that would really.
That would just be 2 minus sine squared.
Yeah. That wouldn't really do anything to help anything. I guess the only benefit would be just they would all be sines, but wouldn't reduce.
I guess if the question specifically only asks for signs.
Well, I'm saying I guess the advantage of having sine written both spots is when you're putting a number in place to get answers, that would be quicker, but. James, what happened? How can this be that tiring? That's actually not true at all. Calc is like by far one of the most tiring classes. Your brain gets very tired from thinking throughout the hour, and believe me, I know, by the end of the day, my brain is pretty well shot. How are we feeling okay about these types of problems where you're just basically putting it in a formula and simplifying? So my guess is what you guys would benefit from the most is practicing the simplifying. I don't think you're going to have any trouble plugging it in the formula. Other than you need to know those 3 formulas for Tuesday. So you've got the 2 formulas from yesterday, which are kind of newer versions of one you already knew. And then you've got these 3. The advantage of these 3 is that they're all very close. The downside is you just have to figure out a way to keep them separate in your mind, like which one's which. Like especially the sine and cosine one, right? Like they're awfully close. It's just a negative sign. Okay, I'll stop there. Tomorrow you'll get all hour to work because I'll be gone on an appointment. So from here until Monday, get 3-4 and 3-5 done. I've got it set up. I put it in Schoology already, the assignment for 3-5, and I attached the answer key already because I knew that I wouldn't remember tomorrow. So you guys should have everything and anything. Come Monday, we'll basically try to go over stuff for the test. This is just a super quick rest of the chapter here. Is that okay? Is there any kind of questions that maybe I'm not thinking of? Anything you guys are wondering about? All right, let's call it. Get to work.